So in today's lesson, we're going to start looking at uniform circular motion and try to start to begin to develop an idea of what this concept means and how it applies when we start to look at centripetal force or forces acting in circular motion. So first of all, when we talk about uniform circular motion, what we're really talking about is motion in a circle that's at a constant speed. One of the terms that's important for us to know in this type of motion is the period. That's the time to move around the circle one complete time. The period is really, you can think about when you start the circle until the time you get back to your starting point, when you've gone one time around the circle. If we know the radius of the circle, r, we can actually relate the period t to the speed of the object in the circle. So how do period and speed relate to one another? The first thing to think about is, what is the distance around the circle? If period is the time it takes to get around the circle, we could take the distance of one time around the circle, divide it by the time, and end up with the speed. Well, the distance around a circle is the circumference, and we have a formula to calculate circumference, 2 pi times r. So what that means is that the speed of uniform circular motion is 2 pi r over the period, or circumference divided by the period. So here we have an example I have on the right hand side where we have the various radius r. I have a few points on there, and it shows you what the velocity is at those various points, 1, 2, 3, and 4 as you go around the circle. It looks like this object is moving counterclockwise around the circle. So let's do a quick example problem. Let's say we have a race car that's driving around a circular track with a radius of 350 meters, and they travel around it in 45 seconds. How fast is the race car moving? Well, if the speed is 2 times pi times r over the period, we know that r is 350 meters. We know the period is 45 seconds. So I could simply plug those values in and get 2 pi times 350 over 45, and I get 48.9 seconds is the speed of the race car in this circular track. This, of course, assumes that the race car drives at a constant speed throughout the entire motion. And when we talk about uniform circular motion, we're talking about objects that move in circles at constant speeds. So quick concept question. If speed is constant, does the velocity need to be constant? And then explain your answer. Well, the answer to that is no, it doesn't. And the reason for this is, think about what the distinction between velocity and speed is. An object can move at a constant speed but change directions. And in fact, in uniform circular motion, if you're moving around in a circle, you can almost think about it as you're constantly changing directions. Since velocity includes information about both the speed of an object and its direction of travel, speed could be constant, but velocity could be changing. What this means is you're traveling the same speed, but if you're changing directions, velocity is changing because velocity includes that information about direction of travel. So that's a quick introduction to uniform circular motion. Over the next few lessons, we'll look at other concepts like centripetal force and centripetal acceleration and look at how they apply to this concept, or how an object can move at a constant speed yet have a changing velocity.